Hello friends, welcome to my channel. Today we are going to design a flat slab interior panels with drop only. We have already done the drop with column head and without drop without column head, right? So we have this type of problem. The same procedure will be the same. We will find the effective depth first by these criteria, case 1 or case 2. Column strips and middle strip will be calculated by this sheet. Size of the drop will be find out. Next, the dead load calculation will be there. Calculation of stiffness and alpha C will be calculated. Step 4. Step 5 is the check for correction due to the pattern loading. If this will be only if live load by dead load is greater than 0.5. Check along the longer direction and shorter direction. Next is the total design moment for which we have to provide the reinforcement. Next slide is the reinforcement calculation. This table will give you the reinforcement along the longer direction, along the shorter direction. Next is the two-way shear check, the punching shear check will be there, and finally the detailing will become automatically by this Excel sheet, right? So let's start. We have to put your data in these shells only. What we have given, the design the interior panel of the flat slab panel 6 by 6 meter. So our panel is the same size, 6 meter in LX direction, 6 meter in LY direction. Live load is 4 kN per meter square. Floor finish is 1 kN per meter square. Width of column size is square column is there with the drop. Column size is 500 by 500. FCK is we have to design for M20 and FY is 415. Next, height of the column below can assume that 4 meter the height, right? So next is we have to find the effective depth of the slab, and in this case the LX is greater than 3.5 and live load is also greater than 3 kN. We have to choose by this case 2. Assume the PT percentage 0.4, modification factor is 1.3 by this graph. We have already done this, right? So L by D ratio is 160. We have to assume greater than this. If we assume 175, assume the bar dia 10 mm generally we used and 20 mm is clear cover. So finally the overall depth of the slab has came around 200 mm, and overall depth of the drop is around 25 to 50% more than that, more than 200. So we have assumed 1.25, that is 25% more. So finally the effective depth of the drop has already been calculated, 225, right? So column strips, that is middle strip and column strip, we have already explained in detail in the last videos. So these are column strips, right? And the drop will always be same as the column strip. So it has been calculated. So width of the column strip along the longer direction, shorter direction, it will be same because our size is same, 6 meter and 6 meter in both sides. So this has been calculated. Size of the drop, I have already told you the drop will be equal to the column strip, 3000 by 3000 mm, and capital D is 250 for the drop. So this is the elevation. Drop is 250 came out, and the depth of the slab is 200 mm. Dead load has already been calculated by these specifications, right? 250 mm for the drop, and it has been calculated as self weight of the slab is slab plus drop 5.31. Total load on the slab this much, and the factor load has been come out 15.47. So stiffness has been calculated. I have already explained you in the last video. For the slab and for the column is 1 calculated. So this is 0.63. Live load by dead load ratio is 0.63. So check for pattern loading is required. So if we done the pattern loading, so no correction is required along the longer direction is being come, and no correction is required in the shorter direction. So percentage correction is required is 0, right? So next is the total design moment. It has been calculated, right? So the formula is m0 is capital W into ln by 8. So it is further clarified as capital W is small w. Small w we have already calculated 15.47. L2 into ln. So column size is D is 500 mm. Ln is the clear spacing between the columns, right? So it has been calculated as 5500 in both directions because these directions are same. So total design moment in the longer direction is same as in the shorter direction. If you change the 4.5 meter and this much is 7 meter, you will find all the data along the shorter direction and the longer direction will be changed, right? All the data will be changed, and total design moment will also be changed. Along the longer direction it is greater than along the shorter direction, right? So in our case this is 6 meter by 6 meter. Next is the reinforcement calculation. By this table, the MOL is 350.95, okay, small d is 175, capital D of the slab is 200 mm, and 225 is the effective depth for the column strip, because the drop will be at the column strip, right? So we have to take the effective depth of the drop 225 for the negative moment in the column strip, right? So these already been explained, the moment calculation. So moment has been calculated and PT percentage has been calculated. It should be, if this is greater than 0.12, that is the minimum percentage of steel, it should be. And finally the AST required has been calculated. If we choose the 12 mm dia, so this is the spacing came out and the AST provided has been calculated, right? So next is, if we choose 10 mm dia, this is the, we are designing the column strip and negative and the positive movement, right? The movement has been taken by this much, right? So in case of middle strip, 57 kN/meter is the movement, and if we choose the 10 mm dia, so this much is the spacing, and again we choose the 10 mm dia, this much is the spacing. If we choose the 8 mm dia, this much is the spacing required, right? So in the shorter direction, the same movement and the movement will be same because the span is same. So if we choose the same along the shorter direction also, because the same directions are there, right? So 10 mm, 10 mm and 8 mm, so the spacing will be same. Next is the check for two-way shear. Two-way shear check has already been done. The safe shear is came out, right? So these are the formulas already been inserted in there. And for the slab, tau c dash is ks into tau c. I have already explained you. Ks is 1. If it is greater than 1, so it will be taken as 1. Tau c formula is 0.25 square root fck, right? So finally we have to compare it by tau v. If tau v is less than tau c dash, then it is okay and safe in shear. Finally the detailing part. Detailing has been done by this sheet. So these are the middle strip and these four are the column strip. This is the column strip and this is the column strip, right? So this is the middle strip, 8 at the rate 180 mm center to center for the both side, right? 8 180 mm center to center in the positive for the middle strip, okay? And if we take the drop and or the column strip, so 12 at the rate 140 mm, this is dark line is negative, that is the hogging portion, because at the support there will be a negative movement. For that hogging reinforcement is required, right? So 12 140 mm center to center, this much is 12 14 mm 140 mm center to center. And finally is this is the section is being given. So 8 180 mm center to center, this dotted line is at the center is sagging moment, so this much will be in the bottom portion, this both. And 10 250 mm center to center, this much is the negative direction, this dark one is the negative direction, because this much is in the hogging at the support, right? So interior panel has been designed. So this is the sheet for the flat slab design with drop only. If you like this video, if you want more design videos, please comment me and please subscribe this channel and for more design videos, and thanks for watching.